Welcome to the Explainer. So today we're stepping right into the ultimate digital sculptor's studio. Imagine taking those brilliant floating ideas in your head and transforming them into incredibly complex, tangible 3D realities using SolidWorks. Whether you're aiming to design a simple mechanical gear or a really organic, swooping consumer product, understanding the core philosophy of this software is going to completely change the way you build. Here's our roadmap for today. We'll be covering setting up your workspace, mastering those 2D sketches, building 3D features, modifying and refining shapes, and finally diving into advanced surfacing and molds. Let's get into it. All right, part 1, setting up the workspace. Before we throw down any digital clay, we gotta get grounded. Your first critical step, setting those units to millimeter gram second. You want total mathematical accuracy right from the jump. It's absolutely crucial to grasp the 3 distinct environments we're working in. You've got part mode, which is for creating your individual pieces. Assembly mode is for snapping all those pieces together into a final product. And drawing mode, that's your 2D blueprints. Keep in mind, though, we're going to spend almost all of our time today acting as sculptors, strictly in that first one, the part environment. Moving right along to mastering 2D sketches. Look, you literally cannot have a 3D model without a solid 2D wireframe blueprint. It is the essential foundation of any CAD workflow. Every single design you'll ever make here starts with this exact same 3-step workflow. First up, select a plane, grounding your concept onto a mathematical X, Y, or Z plane. Second, draw a closed 2D profile like a circle or rectangle. And third, apply a feature to just pop that sketch right into 3D. Now, this brings us to a universal pain point that you absolutely have to master. When you draw, your lines start out blue. Blue means underdefined, meaning they can be accidentally dragged and completely ruined. You've got to use smart dimensions and geometric relations, like making 2 lines perfectly parallel, to turn those chaotic blue lines black. Black means fully defined and securely locked into place. Just be super careful not to over-dimension, or you're going to trigger those dreaded red and yellow errors that will absolutely haunt your nightmares. Okay, section 3, building 3D features. Now that our blueprints are locked in with those beautiful solid black lines, it's time for the fun part. Let's add some digital clay. The extrude and revolve bosses are the absolute heavy lifters of SolidWorks. They're what instantly generate 3D volumes from your flat 2D profiles. An extrude boss simply pushes your 2D shape out in a straight line to give it some thickness. A revolve boss, on the other hand, takes that profile and spins it a full 360 degrees around a center axis. It's basically magic for making things like bottles or pipes. To really get the feature tree's core logic, think of it like this. Bosses add fresh clay to your armature. Conversely, cuts, like an extrude cut or a revolve cut, act as your carving chisels to scoop existing material away. So you build up with bosses and you carve in the fine details with cuts. And to truly grasp the sheer scale of what this software can do, just look at the pattern tools. These eliminate so much repetitive manual work. I mean, if you need 50 identical air vents on a product, you are not drawing them 50 times. You'd use a linear pattern for a straight grid, a circular pattern for something like wheel spokes, a curve-driven pattern to follow a custom wavy path, or even a table-driven pattern to drop features onto exact X and Y coordinates imported right from a text file. Moving on to section 4, modifying and refining shapes. Because let's face it, real-world products aren't just sharp, blocky extrusions, right? This rapid-fire arsenal of modification tools acts as our fine-tuning chisels. You can fillet a harsh edge to make it round and safe to hold. You can use shell to instantly hollow out a solid block into a plastic casing. Drop in a rib for internal structural support so it doesn't crush under pressure. Or if you want to emboss a logo, just use the wrap tool. You're basically taking a raw, chunky cube and polishing it into a highly detailed, realistic part. Now, a quick word of caution when you're blending complex profiles using the loft tool. We've all felt the pain of trying to loft a shape across multiple planes, only to get this twisted, mangled result that just crashes the software. Why does that happen? Because our guide points were crossed. Always ensure your orientation points line up smoothly across your sketches. Otherwise, your loft is going to twist into a totally failed mess. All right, our final section, advanced surfacing and molds. It's time to step into the wild west of the software, proving it isn't just for blocky mechanical gears, but for fluid, organic sculpting too. Listen to this idea. The surface has no mass, no volume. It is just a view to a surface. That perfectly captures a massive paradigm shift in how you need to think about this space. This is entirely different from the solid clay we were just using. Surfaces are zero-thickness mathematical boundaries. They have absolutely no mass, no volume. You're essentially working with digital paper, meticulously stitching tiny patches together. To actually build something with surfaces, you follow this flow. First, sketch free-form sweeping 3D splines. Second, use boundary and fill surface features to essentially stretch digital fabric across those splines. Third, stitch or knit those separate patches into one continuous, watertight skin. And then finally, you add thickness to turn that zero-volume skin back into a manufacturable solid body. That is exactly how designers create incredibly complicated, ergonomic products like a modern water bottle or a sleek computer mouse. Ultimately, mastering SolidWorks means mastering two very different mindsets. You've got to seamlessly shift from the rigid, rule-based block building of solid features straight into the fluid, patch-based, organic contour sculpting of surfaces. You really need both to be a master. And finally, once you have that beautifully sculpted organic shape, how do you actually manufacture the thing? Well, you create a mold. You bring your finished part over into assembly mode, you insert a brand new part to act as your solid metal block, and then you use the incredibly powerful cavity feature to rapidly subtract your organic shape right out of the block. You do this for an upper block, duplicate it for a lower block, and boom, just like that, you've created a functional, ready-to-machine mold. As we wrap up this explainer, I want to leave you with an exciting challenge. You understand the core philosophy now. You've got the 2D blueprints, the 3D solid clay, and those zero-thickness surfacing tools. You know exactly how to carve, draft, pattern, and mold. So, take this roadmap, open up a blank workspace, and start sculpting your own ideas. What are you going to build?